So my name is Jody. I'd like to thank my employer JCAP for the opportunity to speak with you today. I'm involved in a number of open source projects. GeoServer, which I'm here to talk about today. Oversights, which is a library that does a lot of heavy lifting behind the scenes. I volunteer with both the Open Source GeoSpatial Foundation and also the Eclipse Foundation, working with different projects. I'm going to look awkwardly at Ian while he introduces himself. I'm the executive. You see, Jody's replaced my 50-year-old photo that I used to use in the I work for a company called Aspen, experts in place. We mostly deal with local government, small municipalities that are trying to save money. If I'm not paying areas. I'm involved in GeoServer, GeoTools, and I'm a GIS specialist with a human process. So he's been modest. He's actually really knowledgeable. So he asked the question on the left. He's like the person to answer. So there's a number of GeoServer talks. There's this one which you can see what GeoServer is about. There's a state of GeoServer Australia in the world that talks about what is in this GeoServer project. So things we've been working on recently. There's a GeoServer feature fancy, which gives a really fast overview of what's cool and exciting and interesting, or tips and tricks and things like that. And later in the week, there's one called GeoServer used in fun and interesting ways. And that's a chance to see how GeoServer has been used in different organizations, from small to large, to customer solutions, and all kinds of stuff. So, let's start by answering what GeoServer is for. So GeoServer is really a web service that's for sharing your information, for publishing your information. It's open source, and it's for sharing your geospatial data. So if you were here to share a map, GeoServer can do mapping, but it doesn't just stop at showing a pretty picture. It also shows the data, shares the data behind the map, so people can download the data and access it and do their own analysis. And it doesn't just stop at sharing the data, it also allows people to remotely edit the data. So if you're doing field data collection and things like that, GeoServer can be part of that solution. So the important part about GeoServer is designed for interoperability. So the idea is that you leave your information where you have it now. So if you've got your data in local spatial, keep it there. If you've got it in Postgres, keep it there. If you've got directories of shapefiles, I'm sorry, you can still use them, but you should consider doing average or something a bit more modern. The goal is to take the data and bring it together and share it with as wide an audience as possible. So to do that, we actually make use of industry standards. So rather than defining our own way to do web mapping, we use some of these industry standards called Web Map Service, defined by the Geospatial Consortium. But the idea here is publishing using standard a wide range of desktop clients and mapping clients and mobile clients to make use of your information. And we do that in more protocols over time. So we've had a transition period between these XML standards from UGC to more modern REST and JSON standards that will be coming online in the years ahead. So this is the opposite of an often invented here attitude. We don't want to invent anything ourselves. We actually want to go with what's common to reach a wider audience. So we can publish maps. Each data set is going to be published as a layer of content. We can actually gather those layers into a layer group. So you might be doing that to arrange layers into a base map that's pretty to share with people. We do include a little layer preview so you can kind of check the GeoServer is working and what things look like. GeoServer is the rendering engine producing the maps. When you publish your maps, they might show up as a map, and it's a layer of content, but you can actually publish the entire thing as a subset of content. And that's more used for mapping clients and mobile clients. Keep in mind that the map doesn't always need to look like an image. Things like SVG and KML output will actually come out as kind of vectors, all already pre-processed with style. And you can also use it to download things like PDF for printing or vector files. For sharing the vector data, so it actually lets you access the data behind the map using things like XML formats like HTML and so on. And this allows you to do queries against the data sets to select just the data, the information you need. It also lets you do editing. You want to talk closer? Okay. It also lets you share raster data. Okay. So how do you use it? You look at this one? So the GeoServer, when we first started out, provides this configuration user interface. So this is a web mapping application, web application which you can use to configure and set up your data. There's also a REST API available for automation. But keep in mind that this application you see here is not really GeoServer. This is just a setup. The really important thing is the web services that are being published, and we can see those kind of listed as little blocks here, web map service and web feature service and so on. The examples I'm using today are from the Natural Earth project. So I'm going to go through some of the concepts that go into GeoServer configuration. This is primarily set up as a but I only have access to the PDF today, so I'm just going to be showing some of the configuration screens. If we get some time towards the end, I might be able to show more. If not, stop by the GeoCamp and see. So the first concept I want to talk about is a workspace. And workspace is, you can consider it like a folder that you publish information in. So GeoServer can have a number of different workspaces. And you can choose what you're using those workspaces for. You might be setting up a workspace for each web mapping application you're supporting, or each data team or project team that you're supporting that wants to share information. For the XML format, each workspace needs its own XML namespace. So the name that we give a workspace is going to be important. It's going to show up as a prefix on each layer that's published. And that same name is going to be used in the XML documents also. Okay. So when we go to set up a workspace, we're going to go to the workspace screen and click New. And we're going to need to fill in a name. In this case, I'm using NE for Natural Earth. And we're going to need to use some kind of XML namespace. So usually I use the web address of the project team who's providing the data. This is going to go really quickly, this presentation. So the next step, once we've got a workspace, is we need to actually connect to the different data sources that are available. So if we're doing a vector data source, the idea is, in this case, I'm connecting to a directory of shapefiles. Anyone who's connected to a database or Postgres, that we know a database connection parameters. It's really quite the echo here. So this data store name is internal to GeoServer. So this allows you to do things like switch from Oracle Spatial to Postgres, or from a directory of shapefiles to GeoPackage, and no one outside the application needs to know. So in this case, I'm going to ask to make a new store. In this case, I selected a directory of shapefiles, and I provided it a name, culture, and for the connection parameters, it's the file location on this where I have all of these shapefiles downloaded. And when I hit save, I've now defined that data connection. It works similarly if I'm looking with raster information. So in this case, I'm locating a GeoServer store place. I'm going really quickly. I wonder if I should that Okay. So the next step, once we connect it to our data, we're going to go through the steps of publishing the data. And when we publish, we're going to need some driving directions for GeoServer so that we can share your information with others. The information we need, the basic information we need is we need to provide a name, a machine-readable name for the content, and then we can also provide a human-readable title and abstract describing the information to others. The other information we need is the spatial reference system with the information, what the data is measured in, whether it's lat long or maybe meters in your local country projection. And then we also need the bounding information for the data. So the goal here is to share the information with enough detail that people can find out where in the world it is and what it's called, maybe a little bit of information about describing what the information is, so they can decide what they care. So each protocol uses a different name for the data product. So when we're publishing a map, it shows up as a layer. When we're publishing vector data, the layer is called a feature type. And when we're publishing raster information, it's called a coverage. And when we're publishing a tile set, it's called a tile set. But for GeoServer, it's one thing. We publish a layer, and it shows up as all these different protocols. So in this case, with my demo, I'm going to do an add a new layer, and it's listing the content that's available, and I can choose to publish one of those. I can then go to the data tab on the layer screen and fill in the name and title and abstract. I can then go through and double check the ordered reference system information, in this case EPG 4326, and I can choose to calculate the balance either from the data set itself or from the spatial extent for the ESG code. And then I can calculate the that So then when I hit save, I'm done. I've published. I can go to the little layer preview, in this case I can see entrance data set. This layer preview is under the OpenLayers web application. But it's just a chance to see is GeoServer on, is my layer available. It's a simple step if I'm going through and publishing a GeoServer. I need to double check the name and the title and the abstract, and make sure that the spatial reference system balance are correct. Okay. So with all the vector and raster data set published, I can now combine the two things into a base map, into a layer group. So if I go to the layer group page, there's a little bit of a trick here. The layers in the layer group are defined in draw order, so it's not Z order. So if I want the layers to appear correctly, in this case I want to draw the raster layer first, and then draw the vector information on the top. And the user interface does copy that, but it's not very intuitive, so I was making the same after that to fix it. So in this case, I'm going to the layer group page and clicking add new layer group. I'm calling it base map. And then I'm going through and I'm adding first the raster layer, and secondly the state province layer. So you can see that those are listed in draw order. I'm not sure you guys can see with this projector, I'm sorry. And then I can go and check that in the layer preview and see that I can combine this information into a single base map. Okay, so just seeing the raw data is not quite so much fun. If there's any cartographers in the room, do we have any cartographers? Okay. Okay, if you cared about making your map so pretty, GeoServer does offer a very extensive rendering engine, and you can define the styles using a format called SLD. This is intended for machine-to-machine use. It's an XML format. It's not very fun to edit by hand. So we really recommend using a style in language that's intended for humans. There's one called CSS, which is very similar to CSS used for web pages. And there's another one called YSLD, which is a little bit more similar to like a Python way of doing things with very careful indentation and so on. So there are some built-in styles provided, but yeah, you're also very welcome to use a tool like QGIS to generate these SLD files for GeoServer to use. Okay, so for GeoServer, we go to the styles page and click add a new style. We can add that style to a specific workspace, like the one we just created. And in this case, I made one called map color 9, because I wanted to send out a theme with my data based on one of the attributes. And I chose a format called YSLD, which is a little bit more readable. And I hit generate. And I'm sorry, you guys really can't see that, but there's just a few lines of text showing how to style a polygon. And you can see in this case it's kind of white orange. And I can edit that, in this case, to use a function. So I'm using a function called recode to recode from the map color 9 attribute, and I'm mapping 1 to a specific color and 2 to another color, and so on. So a little bit like a lookup table, and when I apply that, I can see that my map is now styled in a little bit more friendly way with different colors for each country. Okay. Okay. And I can choose to publish that. I can use that. I can choose to make this new style the default for my state province. Okay. So, for any developers in the room, if I'm going to answer how does it work, it is a Java application, or Java web application. So I can see at the bottom of the page here, I've got a Java runtime environment, and an application server, which is what Java uses for web applications. The entire program is kind of fit together with a framework called Spring, which is familiar to Java developers. But just one of the advantages here of GeoServer is that it's modular. And so you can actually install more extension, more components, and get GeoServer to do different things over time. Okay. So we've got a number of extensions. So the official GeoServer plugins are called extensions, and these extensions are managed as part of GeoServer. So each time we make a new release of GeoServer, all of the extensions are released as well. So it's very easy to make sure that the two things are compatible, as long as they have the same version number, they're compatible. So just an example of some of the extensions that are available, if you're using Oracle Spatial, there's an Oracle Data Store. If you want to do analysis and processing, there's a web processing extension for GeoServer that you can install. If you want some information on a Spark cluster, there's a GeoMesa extension that you can set up. If you have very interesting security concerns, you can actually put GeoServer into an external security module called GeoFence, which lets you define permissions like based on the area of interest. So the idea is you might give someone edit permission, but only within their municipality. For anyone doing vector tiles, there's a vector tiles extension. So there's a very rich ecosystem of additional modules that you can install to teach GeoServer things. We also have some community modules, which is more for research and development. So these things are still in the process of being constructed, or maybe they're not very well maintained. We originally set it up to help work with graduate students and entering developers, but it's also been used by consulting teams taking on challenges for their customers. So this is kind of a bit more music a little bit, but it's a great playground to see what's available, and if there's any functionality you might be interested in supporting. So there's one here called JDBC Config and JDBC Store, which is used to set up a cluster of GeoServers. If you're really interested in failover and redundancy. There's a backup and restore one, which is helpful for keeping configuration from a testing environment and moving over to a production environment. Dynamic color map generation we talked about. There's one called MapML, which is a document mapping format. I think that one's actually graduated to be an extension. And there are these new family of OGC standards called OGC API. And I think the OGC API features one is pretty close to being able to different use. The standard itself is what it's all about. Any questions about that? Anything people are looking for? So GeoServer itself is brought to you by people. In this case, a project steering committee. And it is set up as a full committee of the open source geospatial foundation. So this project steering committee is formed as part of the open geospatial foundation, with a chair and that kind of thing. We do try to keep a mix of skills in the project steering committee, so developers, users, managers, and so on. So we try to have a balanced leadership. We do have a strong history of collaboration. The project was originally set up by a nonprofit in New York, and then different companies added to the project over time from around the world. So we try to maintain an active R&D scene with research labs and companies and so on, joining to add new features. So it's always been set up as a vendor neutral project. Okay. So just in terms of trying it out, if you go to the GeoServer website, there's a binary download that you can download. You need to install Java first, but then you can run it. And that's really intended to let you try things out, see if you like it. So you're totally welcome to use that in protection. There's also a web archive, and so this is more the formal Java way of sharing a web application. And so if your organization has a standard application server like Tomcat, you'll be downloading this and providing it to your IT team and installing GeoServer into Tomcat. We don't have a Windows installer in there, but we no longer have a Mac installer. So, yeah. There is no official Docker image for GeoServer, we have anyone wants Docker. And there's a few companies, such as my employer, that offer GeoServer hosting. So there's a wonderful GeoServer right on the So thanks. I think I've got my 5-minute warning, so we've got a minute to take questions.